Wait, if you're thinking about installing another Claude skill, you should look into writing rules first. This is what a rule looks like. It's a line in my claude.md. It tells me when to clear my context before the next message resends my entire conversation for nothing. A Claude Code hook fires it the moment I send a prompt. Same idea works in Codex. I accidentally created it when I was looking at the viral tool that turns your AI's context into pictures to save tokens. That tool lied to me. 3 of the 4 errors it made had 0 warnings. A silent failure means you start building on top of a lie without you knowing. Before it touches my workflow, I ran it through 15 minutes of blind protocol. The tool didn't survive, but I walked out with something better. And here's the thing, I wanted it to work. I already had the perfect job in mind. I had a question that was bothering me for a while. I kept around 12,000 snapshots of my own prompt history, months of talking to the machine, sitting in plain files. Could I turn all of that text into images and let the machine read it from there? One cheap glance that gave my AI the entirety of my prompt history. At least, that was my vision. A billboard made of IDs, dates, and dollar figures. The exact thing you just saw come back wrong. The tool in question is called pxpipe. Its function is straightforward. It renders AI context as images. I asked my agent to literally, word for word, check this skill, does it work, and can we use it? Let's run through the protocol. The first move is always the easiest. Most people won't read an engineering README from top to bottom and walk away with insight. At this point, now that we have AI, they're much better suited to that task anyway. So I hand the repo to my agent and ask it straight. What does this thing do, and can it deliver what it promises for my files? And then, in the fine print, they tested it on ID codes, the random strings of letters and numbers where every single character has to be right. Their own run got 2 out of 15 wrong. The things that undermined the headline were sitting in the tool's own documentation this whole time. The author published them, but nobody usually reads that far, including me. That's the key. You don't have to read the docs, just ask the machine the right questions. pxpipe is telling the truth about itself. The biggest issue is that the hype cycle around the tools set the wrong expectations. The README is about what happened with their files. What happens on mine? Naturally, the second move is to reproduce the core claim yourself before you believe anyone. I built the process so that it can catch the actual lie. You can run this exact experiment on your machine. The script is rendering text from my corpus tool onto an image, and every exact value is getting randomized and written to a truth file the agent doesn't see. The agent reads the picture, transcribes all 15 values, and only then does the truth file open. There are 2 images on the same canvas. Same text, but 2 densities. The catch is that a canvas costs a fixed number of tokens no matter how much text you draw on it. The exact measurements are on screen. Image A uses moderate compression settings and has 100% of everything correct. Image B is substantially denser. This is the territory where savings start to mean something. The results show it only got 73% correct. Look at how it failed. The letter B read as a 0, a 9 as a 0, and so on. Confusable symbols became swapped. Let's give credit where credit is due. It flagged the checksum as shaky, but 3 misses came back looking exactly like the right ones. The natural response is, so what? Well, a tool that fails loudly gets caught. These, however, get accepted as truths, and everything I build after them is affected. Traditional software engineering has a name for the rule that this breaks. It's called the fail loudly rule. So, what did we learn? The denser you pack the image, the more you save, and the more it misreads without telling you. The savings and the reliability are a direct trade-off. Then, the question that flipped the whole evening. was, what was I comparing this against? The plan was 12,000 snapshots as images, but when I have a question from my history right now, I'm not reading 12,000 of anything. I'm searching for it instead. Let's break that difference down. The search is scanning the original text and handing the model just the snapshots that matter. The image is handed the entire context as pictures. Now, these two aren't fundamentally competing with each other. The search method came up with 3 snapshots out of 12,000. The grep command is a filter used to search for patterns. Imaging is a compressor. A filter finds what matters and costs you almost nothing. A compressor gives you a discount on reading everything as a whole. These are different jobs entirely, and you can't grep a picture. So why do we go through all this trouble if dense images ultimately fail? It's because a hammer is still a hammer even if you don't have nails. You don't just throw it away. You wait for the right job to use it. There's exactly one question my search can't touch. If I don't know the keywords, I wouldn't know what to ask. Suppose I'm wondering about something I'm circling but not noticing. To get answers, it has to skim everything cheaply and accept some blur. That's when we use imaging. This is useful, so it went in my back pocket, which left one question still open. What happens when you map this onto your billing model? I don't usually pay per token, and most of you probably don't either. I'm on subscription plans, so 70% cheaper doesn't translate fully. At best, it stretches my plan limits. Except, providers already discount repeated context. It's called prompt caching, and what it does is it discounts exactly the text this tool would convert. If you turn your history into fresh images, you lose the discount you already had. And remember that silent misreads persist. One failed agent run can cause it to hallucinate the wrong information. Now let's take a step back, because every problem we just hit had a different shape. The savings depended on my billing. The misreads depended on how hard I pushed the density. If this is about capability, there would be no problem. But there's an imbalance. A skill adds to what your AI can do. Skills are flashy, and it's easier to say yes to more capabilities over no. The missing half are restrictions, rules, your own taste written down where the machine can act on it. If you keep stacking capabilities without assessing them, the system gets stronger and less trustworthy at the same time. If you can't trust your system, you won't be able to use what it gives you with confidence. Understand what the tool is for and use it on the right problem. That's a complete result. The most useful thing I got from this test was still coming. Let's look at it from yet another angle. If compression wasn't going to stretch my plan limits, we need to look at the sessions themselves. Every prompt in a long session resends the entirety of its history. Past a certain point, each exchange costs about 10 fresh sessions worth of tokens just to keep the old context. But do we really need that context? And how do we know when to keep the context or let it go? These are my working numbers on a 1 million token window. The bands are on screen. Below 100K, you leave it alone. That's normal working depth, and clearing there costs you more than it saves. At 100 to 200K, clear at the next natural stopping point. Past that, and the AI will start guessing and making mistakes because it relies on its own messy summaries instead of your actual files. Finish the thought you're in, then clear right away. Look at it like this. The moment the topic changes, all of that old context has little to no value. Then I realized that I couldn't trust myself to remember the rules. That's why I handed the rule to my AI. There's a script called context tax in my setup that watches how heavy a session has gotten. And when I type a prompt that opens a brand new topic, the agent reminds me to clear the context window. I thought a tool and skills could help me with one of my problems. It ended up being a rule I use every single day. Testing a tool is always useful, even if you decide not to use it. Trying to understand it forces you to look closely at how your own process works. That's how a shelved tool ended up improving the system anyway. I call this meta-tooling, and this is what it looks like. Using AI to refine the system you work in, and not just the work itself. Most of the work is building. Meta-tooling is the other half. Every tool you let into your workflow changes it, for better or worse. The next skill is a click away. Before you install it, ask what rule you'd write instead. The tool I tested is in my back pocket. The context tags runs every day. Links in the description for this and my other tools, completely free. Drop me a comment with the one rule you'd keep if you lost every skill tomorrow. If this helped you, like and subscribe. And as always, I'll see you next time.